All right, well, Dr. Jones did call and visit with me a little bit, asked me to participate, and I appreciate the invitation. Had fun here at this conference. Jeff, I think it was 2015. So that was, I'm really impressed with your Kentucky Cattlemen's Association, and we appreciate, watch, kind of monitor what the extension group is doing here in Kentucky and model some of those things actually, because you all have a good program here and it's well thought of. So, all right, so Dr. Jones' request to me was to talk about basically cow efficiency, and I suggested this title to Jeff. You could probably look at this title a number of different ways, but I'm basically just going to look at it from a nutritional or forage utilization efficiency. That's kind of what we're going to focus on today. Normally when I'm giving a cow efficiency presentation, we talk a little more about fertility, but we've got experts in the room that can cover that some other time, because I got too much really cool stuff, and we all know that nutrition is far more important than genetics or reproduction. But that was a joke. But
I got it.
So good. So let's first lay out a job description then for a cow. You may differ. This is just my opinion. A minimum wage cow or one that can minimize inputs and at least maintain or improve productivity. So first of all, we're going to say she needs to wean a healthy calf every 365 days for 12 consecutive years. That's not easy to accomplish, right? We have one producer not too far from where we live, a seed stock producer. They will not flush a cow until she has weaned 10 calves in a row. How cool is that? Now that's a commitment to fertility. Problem-free requires no additional handling or medical treatment. Low cost requires little supplemental hay and feed. That's what our research program is focused on right now, and I'm going to spend some time talking about that. Of course, they have to be able to adapt to your environmental stressors. We don't have very much fescue in our part of the world, but I know that you do. Humidity, parasites, disease, 30 below in Montana, and so on and so forth. Get too fat in the good years and thrive in the tough years. So, if she can't perform well, thrive, maybe not look great, but in the really tough years, you're probably going to have to intervene from a nutritional standpoint at least, and what I consider to be artificially modify the environment to help her along. And the purpose for doing that is to what? Is to avoid reproductive failure. I'm afraid I'm going to get off on my soapbox here if I'm not careful, but I think a lot of our extension guidelines over the years, at least where I'm from, have maybe actually encouraged that. We have encouraged, well, if your cows don't look good, just increase the inputs. So what we wind up doing then is maybe selecting cattle that we like, and not necessarily selecting cattle that are a good match to our environment. And then finally, the product, or the primary product would be to produce steer calves with the capacity to gain on grass, convert into fives. You'd like for them to gain 4+ pounds, and convert into fives, never need to be treated, produce a large, then high quality carcass. And carcass weight's still a big part of profitability in the feedlot industry, and of course today there's a lot more emphasis and value added in terms of marbling and some relative to yield. Okay, so I'm not gonna spend much time on fertility. Like I said, there's other folks that can talk about that, but I want to get to some of these other things that we've been working on here, and I think maybe interest to you and different than what I shared with you when I was here last. So I'm just going to jump by that. Let's just start off with cow size. Something that gets talked about a lot. Let's look at some of the details relative to cow size. Depends on your perspective. So, when you're talking about cow size, you're thinking about cow size, I think you need to separate individual animal efficiency from overall herd efficiency. okay? Because, on average, most of the economic analysis suggests that more moderate-sized cows are going to be more profitable. Yes, it probably does vary. That moderate-sized cow, maybe 1,000 pounds in the south and 1,250 or 13, something like that in the north. But I don't think it varies all that much. That's one thing to consider. But if you're talking about individual animal efficiency, it's a whole different ballgame. I'm going to show you some data here in a bit. But basically, we've discovered that there are little cows that are terribly inefficient. And there are some great big cows that are really good. Okay? Let's see, what else did I have on there? Weaning weight, post-weaning growth, carcass weight. I mean, this is why we talk about cow size. Really, most of the time in the economic analysis, cow size is just a proxy for feed intake. They use it to guess how much those cows will eat, right? And that's why it's important. That's how those economic indexes are calculated. But there's a lot of variation from cow to cow. Cold carp cow market value obviously is important, and yes, they do bring more when you take them to market. What I caution our producers about is that, but you have to remember to grow that 1,100 pound 3-year-old to a 1,500 pound 6-year-old is not free. Actually, the efficiency of that growth is fairly poor, and it's relatively costly from a cost of gain standpoint. And so it's not free. Just because a bigger cow weighs 300 more pounds, yes, you're going to bring a lot more, but it costs something to get there. And then obviously bigger cows are associated with a little bit with faster post-weaning growth, and actually the genetic correlation between carcass weight and cow weight is pretty strong. I think the genetic correlation, at least in the Angus breed, is around 0.6. So it's pretty strong. Okay, so what's going on now in terms of cow weight? And I'll just show you the genetic trends of a couple of breeds here that report this genetic trend. And basically all I want to show you, what sort of seems to be the never-ending arms race for growth in the cattle industry continues. Okay, and you can see it there. This is the yearling weight genetic trend and the mature cow weight genetic trend, and they track right along with each other in all the breeds that report these. And everyone is doing this. Okay, everybody is, there's two camps. There's kind of the minimum input camp, which is a smaller group, but the majority of the industry in the bigger camp, obviously the genetic trend wouldn't be headed north if that weren't true. And so you can see that, and this is the Angus genetic trend, yearling on top there, and the cow genetic trend on the bottom. And they just track side by side. This is interesting. Angus actually reports a mature height and yearling height EPD, which is really nice to look at. It's interesting to me. I was, in the 70s and 80s, Jeff, we were probably in 4-H, and that was what Dr. Tadashek from our department considered. This is what I told you last time I was here, but he considers that the second era of insanity in the cattle industry. What was the first era of insanity? It was before that, right? What kind of cattle? Belt buckle cattle. You've heard this. You're cheating over there. But when we were in 4-H, you couldn't hardly reach the halters, right? And judging cattle was simple. You picked the big one. It was simple. And you can see that happening there, but the industry responded once we discovered all those challenges that were associated with that. And you can see that, at least in terms of height, and you go to any of the livestock shows now and you see that cattle have definitely moderated. It looks like, now I don't know if that trend will continue or not, but in the Angus breed at least it looks like it's ticking up a little again. Interesting. It'll be interesting to see where that goes the next 2 or 3 years, see if that continues. But cattle are definitely getting heavier. This is a genetic trend for cow weight and red Angus. So they've apparently put some selection pressure against increasing cow weight, and their breeders have bought into that. And so I don't know what's going on over there, Dr. Jones, at your farm, but looks to me like, now you might argue that maybe it's starting to swing up a little bit too, but pretty significant increase up until about 2014, 2015. Well, here's the bottom line in terms of cow weight, and that is these genetic correlations are important because weaning weight, pretty strong correlation to feed intake, then post-weaning gain, also strong correlation to feed intake, which you would certainly expect that. And then I mentioned the mature cow weight genetic correlation with carcass weight, but there's also a strong genetic correlation with weaning weight at about the same at 0.61. So what does that mean? What does that mean to you then? If you continue the never-ending arms race for growth, I mean, really what it says is that in the absence of control for feed intake and cow size, continued aggressive selection for growth will result in heavier cows. They're going to continue to get heavier if we continue down that road without control for feed intake and cow size. Greater appetite, more acres required per cow, more rapid post-weaning gain. You know, that's a good thing. You would anticipate that some of that would come along with continued selection for growth and then heavier carcass weight, right? So there's some antagonisms there. Certainly a cow, if you're a cow-calf operation, particularly in a sell-at-weaning context, you know, that's going to be more important to you depending on what kind of relationship you have with the person that purchases your cattle and whether you can take advantage of that increased growth or not. So here's the evidence, perhaps, and that is the genetic trend for feed intake. And, you know, sure enough, we continue to aggressively breed cattle with greater appetite. And that's what that genetic trend suggests. There's the genetic trend for feed intake in Angus. I didn't bring the Hereford, who reports this also, but it looks just like that as well. So what to do? Let me just make a suggestion. What to do about this if you're a commercial cow-calf producer and selecting bulls when you go purchase herd sires. So the industry has basically, let's see, curve benders, the term curve benders. What does that mean? What's a curve bender bull? Well, it's certainly extremes in terms of birth weight and probably yearling weight growth, right? I was in charge of calving the heifers at Montana State University when I was a young man. I was a student manager up there. And let me tell you, it was a disaster, okay? That was a long time ago. But we had a lot of dystocia. We slept in the office. Every 3 hours, somebody was out there checking heifers, and we had to call the vet for C-sections quite a bit. I didn't know it then. I thought it was cool and fun. I was learning a lot and really into it. I wouldn't want to do it today, but it was a disaster. I heard Dr. Jones say yesterday they've calved all their heifers. So far, you've not touched one, at least in terms of dystocia. We don't even watch our heifers at night now. The industry has knocked it out of the park. Okay, you can find, at least I'm thinking Angus breed EPDs, you can find a calving ease direct 13, 14, which is really good, sire with a 0 or -1 or something, birth weight EPD, and a plus 150, 160, 170 yearling weight. I mean, they're everywhere. They'd be younger sires, of course, but they're everywhere. We can do the same with cow size. Okay, so this is just a group of Angus bulls that are fairly well proven. They've been used quite a bit. I don't remember the criteria exactly on this. So I think 0.6 accuracy on milk EPD is where we selected these bulls. But that just shows you the mature cow weight on the X-axis or the bottom axis there, EPD, and here you've got yearling weight EPD on these sires. Where's the sweet spot on that graph? If you're trying to maintain or increase growth, but maintain cow size or reduce it, where is the sweet spot? Well, if you want to, well, I guess you got to know where breed average is. There's breed average for mature cow weight, a little over 50. So you want to be to the left of that, right? If you want, especially if you want to put downward pressure on cow size. This is a little over 100 is the breed average for yearling weight EPD. You'd like to be above that, right? So the sweet spot is top left. And there aren't a whole lot of sires that you could make pretty substantial progress in that direction, but there are some. And we said the same thing about bulls 30 years ago in terms of curve bender, birth weight, yearling weight. We said the same thing. And we can do that. More breeders are going to have to report their cow weights probably to help us get there, but we can do it. All right, let's talk about weaning weight. Now this topic's pretty interesting. I think it's fascinating. See what's going on in the world right now. First of all, this is the adjusted phenotypic weaning weights for two breeds. And I just put two on here because it won't get too messy. What's happening? Phenotypic weaning weight. These are actual adjusted weaning weights, annual average. So it represents thousands and thousands of cattle. Are you surprised? It's going up. We're selecting aggressively for growth. But the rate at which it's going up is slowing down, isn't it? Interesting. Okay, so we worked with the K-State Group and Superior Livestock Video Auction here to publish this paper maybe 2 years ago now. And we just took the annual average projected delivery weight for these two different regions of the country. In order to make it into the data analysis, the sale lot had to say not weaned or unweaned, okay? So the projected delivery would be for balling calves. And our assumption was that these superior reps had a pretty good idea of people they had worked with for a long time what their calves were going to weigh. And so that's our proxy then for weaning weight. So I'm not worried about the implanted versus not implanted group here. Probably the difference between those two lines over time represents more than just implanted. It's probably maybe better managed operations that also happen to use implant technology. And so their projected delivery weights were considerably heavier. Are you surprised by the trend? That's in kind of the north and northwest, mountain west segment of the country. As you can see the states there. Would you have guessed? It's been flat since about 2005, 2006. Anybody surprised by that? I was when we first analyzed this data. For whatever reason, and we've talked to lots of producers from that part of the world, lots of superior reps, and they just all tell us, well, yeah, if we weighed them last year, we can be fairly certain, unless there's a big drought or something, they're going to weigh about the same again this year, in the face of this never-ending arms race for growth. Interesting. This kind of suggests that perhaps the environment is limiting in terms of weaning weight rather than the genetics, right? But Mother Nature never lets things be simple. This is what's going on in the south. It's kind of the south-central part of the country. I mean, the slope of those lines is about what, if you were to draw a linear regression through the first segment of the previous slide, it's about the same rate. So the increase in calf weaning weight in the South continues. Why? Why are those two different? Well, I don't know. I don't have a good answer. Be interested to hear what you think. Might be the difference here. But it seems to me like we're just trying to catch up in the South. They were performance testing cattle for, well, growth and other performance traits in the North very aggressively. Well, back when I was in Montana, it was very aggressive and had been for a long time then. I think in the South in general, our genetics, well, I can tell you for sure we have replaced a good number of Bos Indicus influenced cattle with more English, Red Angus and Angus cattle in the South. And those cattle, those breeds have been selected more aggressively for growth compared to Bos Indicus. So that's probably one reason why it's different. Very interesting. Take-home message from that section, stark differences among regions, no doubt. You know, really that doesn't matter too much. What matters is what's going on at your place. And if you have good records, you can do this yourself for your own place. You're going to have some years where your weights are a little higher, some where they're a little lower, you know, based on the year that you had and so on. But if you can track it over a long enough period of time, you'll begin to see those trends. And you need to know if it's increasing on your place. And if it is not, maybe shift your focus to more of the cost side of your enterprise rather than the production side. Either that, or make sure that you have a good connection with whoever's buying your cattle or retain ownership or something to take advantage of what you're giving up there at weaning, right? So if you have cattle for growth, you need to be able to take advantage of it. Weaning weight phenotype is easily manipulated. You know, in our part of the world, you can turn fall-born calves out on wheat pasture and not quite double their weaning weight, but you can increase it dramatically, just as an example. So there's my plea for, particularly if it's a sell-at-weaning operation, Kansas State and lots of other economic analysis and cow-calf enterprises tells us that the cost side is a lot more impactful, generally speaking, than the production side. And there's going to be some exceptions to that for those of you who take advantage of retained ownership and so on. Our data says that each 100 pounds increase in cow weight generates somewhere in the neighborhood of 6 to 28 pounds of additional weaning weight. Okay, does everybody follow me there? Each 100 pounds more cow weight. If we just go to a ranch and we weigh their cows and their calves at weaning, we do it year after year, and we've done multiple ranches around, what we find is you get 6 to 28. The more restricted environments, it's more like 6 pounds. The better environments, eastern Oklahoma, longer high-quality forage, grazing, and so on, more like 28 pounds. But the cost of the extra 100 pounds of cow weight is around $50, give or take. And so it's really hard to pay for another $50 with 28 pounds of calf produced, okay? All right, milk. We're going to skip over this one. I don't have time. I could spend an hour on this subject. We're working hard on this topic in the cow-calf industry in our research program. Let me just say that real quickly, yes, you can definitely overdo milk. Maybe I think we've learned recently that it might not be quite as dramatic of a negative as we thought originally. But there's no question, if you overdo milk in a commercial cow-calf operation where a cow spends a lot of her days throughout the year close to maintenance, okay, close to a body condition score 5, milk can be overdone pretty quick. Otherwise, you're going to have to intervene and artificially modify the environment, or intervene more. Okay, so Jeff, he's already flashing me here. I mean, showing me that I'm about out of time. So I'm going to speed through some of this, but I want to show you what we've been doing. This is the kind of work that Austin did when he was there at Oklahoma State. We've been working hard on individual cow feed intake and efficiency and so on. This is not Austin's study, but those are the kind of facilities he got to work with. Also, let me show you what we're doing now. We've upgraded a little bit. This is a cold, windy day. She's filling those hay feeders, our individual hay intake system, with that hay unroller. It's not a very good video maybe because of a really cold, windy day there, and maybe all the hay didn't hit the basket, did it? But we've gotten better at this. That was a graduate student that actually helped develop that system, and we're making good use of that now. I think we have a really unique individual long stem, dry grass hay diet. I'm going to show you some data from our first study with replacement heifers. They got hay and mineral, okay? We challenged these heifers to thrive on a forage diet. Before we do that, I think I got enough time here. We're going to have a little judging contest. I want you to look at A, B, and C. These are 3 cows of a group of about 50 we tested. There's one 7-year-old here. This is the 7-year-old. There's 2 3-year-olds. Half of these cows were 3, half were 7. I'm just going to show you these data on these 3. You pick out the most efficient cow, okay? See which one you like the looks of the best. Catalog A, B, or C in your mind. I'll show you the data. Okay, here are the results after tracking these cows for nearly a year. And now, I'm going to give you just about a minute, and you look through their data and see if you change your mind. I wish everyone could do this with all of their cows. But let me tell you, this data is hard-earned. That stuff is not easy to get. Austin can tell you. Okay, we're going to have to move along, but first of all, the 2 3-year-olds are going to be big cows, right? They're already 1350, one's pushing 1400. The 7-year-old, she's 1465. She's a pretty big cow. She doesn't really look all that big in the picture, and it really actually just to walk up to her, she doesn't look that big to me. But they're pretty good sized cows. Milk production, 33 pounds is a lot of milk for a 3-year-old. Holy cow. That is a lot of milk for a beef cow, 3-year-old in particular. That cow she is getting with it. She's highly productive. But she's a little harder keeping, right? Body condition score, and you could see that in the picture. She's continues to be a little harder keeping today. Those girls would be, they would be almost 6 now, the 3-year-olds. All right, so this cow, she looked good in the picture, didn't she? From a flesh standpoint, she's a little easier keeping cow. Well, you'd think because she doesn't, where's her milk? She doesn't give near the milk that the other 2 cows do. These 2 cows are doing a great job from a weaning weight standpoint. This cow, not so much, probably reflected right there, at least partially due to that milk production. So what haven't we talked about yet? Yes, ma'am. Just like a dairy farmer. Milk machine, yes, ma'am. Yeah, we've done some weigh, suck away technique, but we like the milking machine better. And yeah, we've visited the emergency room a number of times. They gradually get used to it, though. You can train a beef cow just like you can a dairy cow. So okay, this is pretty impressive, isn't it? Now, obviously, this is an extreme example. I picked out these 3 cows because of these big differences. But she's doing a great job. And we've probably been selecting cows for weaning weight that they produce for a long time. Now, I think in recent 10, 15, 20, maybe 30 years, people have also been selecting for fleshing ability in those cows and forcing them to do both. And that's really a good thing. But she's doing a great job, but boy, she's going to eat you out of house and home, right? I mean, just think about this. Let's just take this cow. She doesn't wean as big a calf, or didn't that year. But if you had a ranch that could run 1,000 Bs, you could run 2,000 As. Think about that for a minute. I mean, is that cool or what? And she's maintaining her body condition, right? Now, if her fertility is efficient, I'm happy. Wes, are you happy? Sweet. That's really cool. Now, again, it's an extreme example. You can't just flip that switch overnight and select all those cows and make that happen. But it just shows you the potential that perhaps we have. Okay, I'm glad I have that many left. Excellent. Okay, so he flashed me again. So do feed intake EPDs work for cows? Let's talk about that. Oh, wait, I forgot to ask. Did anybody change your mind on the cow that you liked the best after seeing the data? Handful? No? You got it right, huh? First time. Okay. I actually think the 7-year-old is phenomenal. She's good. She's not hard keeping. She's not the easiest fleshing cow, but dang, she's doing it all too, right? And she's big. So see what I mean? It isn't just about cow size. It's not just about cow size. It's a little more complicated than that. Okay, so I want to share this with you right quick. Feed intake work for cows. We've been working on this for some time now. I think we're kind of starting to get a little better picture here. A lot of other groups throughout the country have been working on this topic too, and I think the industry is actually making some progress. So I'm going to show you some data here. What you've got is in this table is correlation, and these are simply phenotypic correlation, okay? Not genetic correlations. These are phenotypic correlations. So feed intake and gain when consuming forage versus mixed diet. So let's just stay in this column for now. Keep from confusing you. This is the correlation between forage and a mixed diet, meaning something like, let's call it a bull growing ration. Okay, a pretty good ration with 30, 40% maybe roughage of some type, and then the remaining would be some concentrate combination. Okay, everybody follow me? That's the difference between forage and mix. Now, some of these projects would have used really high quality forage like wheat silage, or some consider corn silage to be roughage. Well, let me tell you, corn silage is not a forage diet. Corn silage is nearly 50% concentrate on a dry matter basis to begin with. So we look for studies here that have more of a almost no concentrate, very little concentrate. So the correlations are all positive, and the little star means they're statistically significantly different from zero. So we have confidence that if those studies were repeated, we should get the same or a similar answer. Okay, and so it's positive. So I think at this point, I think we can say, and there's a couple of studies that have the genetic correlation, and they're higher than these in this column that I'm showing you here. So I think if you're selecting for using the dry matter intake EPD, whatever direction you want to go for feed intake, if you want it to go higher, you can select it and head that direction, and it will result in the same change in your cows. Same with going or putting negative pressure on feed intake. You can do the same with your cows. Now, it's not perfect. I'd like for that correlation to be a lot stronger. And we think that the work we've done so far and the other studies have been published, the closer you get to the mixed diet, anything you do increases the strength of that correlation. If you chop the forage or process it, grind it, if you add back moisture, if you feed silage, any of those things that brings it closer to the texture and or energy concentration of the mixed diet, higher quality forage is going to be a stronger correlation. The closer you get to where our cows have to make a living for 6, 7, 8 months out of the year, With long stem, dry, low quality forage, the lower that correlation gets. But it's still positive, and I think that's a good thing. Okay, what about average daily gain? Now this is a correlation for weight gain between cattle that are consuming forage or a mixed diet, okay? Follow me? Sometimes that's kind of confusing, but that's correlation for weight gain. And it's not so positive. Very interesting. So all these years we've been selecting never-ending arms race for growth based on primarily higher quality diets, primarily, because that's how our seed stock are tested most of the time. The correlations appear. These are our 3 real recent studies down at the bottom here. This is Amanda Holder's 2 studies with cows. We did crossover design where half the cows got forage for a while, half the cows got concentrate, went for quite a while that way, then we flipped the treatments, and so the same cows got the other diet for the same period of time going forward. 2 studies like that. The one study, and they're both negative, this one's not significant. We just finished a week ago Tuesday, Emma Briggs weighed off her heifers, the correlation for weight gain between concentrate, and these are replacement heifers, concentrate and forage, long stem, grass hay, was not significant. Okay, it was slightly positive, but not significant. I think that means we have an opportunity to select cattle that perform better on moderate to low quality forage. I think that is a next or a new an opportunity for the industry to move forward. The other thing I think we've discovered is that there are some cattle that can do both really well. Okay, notice this is close to 0, right? What does that mean? Well, if it's close to 0, it means some of those cattle were really good on the concentrate and terrible on forage. But it also means that about half of them were above average on forage. Okay, some cattle can do both. And the next thing we need to do is figure out how to find them. What you can do, I think just a simple thing, opportunity for you folks, measure weight gain some period of the year where they're not pregnant, they're not lactating, not during the breeding season, maybe right now. If you're supplementing a little and feeding hay, if you can measure weight gain through the winter, let's say, for the heifers that you retained, you'll get a number like that, and you can rank your females for weight gain on forage. Simple. But why not select cattle that can do well there? Won't they turn into cows? We hope. We're going to follow up with this heifer project in the next few years, measure the heifers, and bring the cows back as 4-year-olds and do the same during gestation and lactation and see if we get a good repeatability. I think we probably will. This is our hay intake system. So this is Emma's study, and I just kept this real simple. I just want to show you, this is hay intake on these 50-some heifers. That we had one heifer eat only 10 pounds a day, and this is for 72 days straight after, I think 2 weeks of adaptation, so actually 86 days straight, a feed intake study on that hay. Some heifers, one heifer ate 10 pounds. We had another heifer eat about 22 pounds. And you couldn't tell by looking. Okay, and then here's the weight gain. Now they didn't gain very well. All they got was grass hay. They looked pretty rough at the beginning of the breeding season. I was thinking, this might not have been a great idea. Dang, there's some heifers that do pretty well on straight hay, right? There's some that don't do worth a darn. Look at this girl. She gained nearly 1.5 pounds and just kind of ate average, right? How would you like to have 100 of those? Not a bad deal. I'm not too sure if these were my heifers that I already had selected them for everything else you have to go through to select quality replacement heifers. screened them for everything else. If I had this data, I'm not too sure I wouldn't just draw the line right here, Jeff. Half a pound a day and up, and say, these are my keepers. These are going to go to, they're going to be stalker heifers. I mean, why not? They've proven that they can perform reasonably well out there on grass. And yeah, you might lop off a few of the big eaters, but that's pretty cool. Actually, even though we might not get a very good pregnancy rate, because they look pretty tough. But then we turned around and we put them on a concentrate or a mixed diet, and we'll have that data. Okay, last thing, and I'll sit down. Amanda had, she did a master's degree as a wheat breeder. She did a genome-wide association study finding a wheat disease, or finding the markers for disease in wheat. And she came and asked if she could do some work on feed intake in cattle and do a PhD. And I said, yeah, you could probably help us a lot. So this is her data. And I'll try to just keep it real simple. It's over my head. Actually, this is RNA sequencing data. And what she did with those cows, she measured the correlation of concentrate versus forage. She also took a muscle biopsy. And then she ran those tissue samples through RNA sequencing. And then she looked for genes that were upregulated or downregulated to see if she could figure out what makes a big eater cow a big eater cow. And a really cool thing that she discovered is this little gene right here. See the blue number 1? That is the sequence or the path for glucagon-like peptide 1, GLP-1. Okay? Now, my understanding is that GLP-1 turns out to be a satiety signal to the brain. It's usually found in the small intestine and the hypothalamus in the brain. She found it in muscle in these cows, and it was downregulated in the big eaters. The biggest eaten cows in her study downregulated the satiety signal. You get it? So the big eaters weren't getting the signal. Stop eating. You're full. They weren't getting it. So they just kept right on. They just kept right on. Pretty cool. Where we'll go from there with that, I'm not real sure yet. But pretty interesting. Okay, so there's my summary. I'll just let you read through that, some of the things that we've learned. And again, I appreciate the invitation. Jeff, thank you.
Thank you. Fantastic, and a way to make us think a lot about what we're doing on our farms and how we might make those cows be more efficient. We do have time for just a couple of questions here now, and we'll have a question session at the end for all the speakers. Joe Kenneth has a question back here. Who's got some? Who's running our mics back here now? Go ahead, Joe Kenneth. You can probably speak loud enough.
Yeah, you talked a little bit about correlations on cow size and growth. What are your thoughts on selecting cattle based off, say, the Angus-based dollar maternal, and using like a dollar energy constraint to select input and profit at the same time instead of looking at phenotypic characteristics?
Well, I may have to have you repeat it a little bit. I'll just say this, and Dr. Bullock and others in the room can jump in here. But I think actually anytime, if you want to make genetic change, those economic selection indexes are going to be much better, more reliable than any phenotypic trait you can look at. We still have a few hangers-on, people that say EPDs don't work, but for crying out loud, folks, they work. If you pick out 100 animals, you're going to have a few that aren't right in the middle. There'll be a bell curve. But if you have 100 animals, the bell curve is going to be pretty accurate on an EPD. So this economic selection indexes are based on those. But just see, you were asking about $M versus $EN.
Yeah, so you were talking, where Talking cow size and growth, where you selected those outliers in the top left, couldn't we also shortcut it from a commercial producer? They only really would have to look at two numbers in a sale catalog, which would be dollar maternal selecting their profit and dollar energy selecting their feed cost.
Gotcha.
So they could select outliers based on those instead of having to go through, well, does this one have enough growth? What's the balance?
Right. So, I mean, everybody's going to have their opinion about the components of those dollar values. I have mine on dollar M. I think it's a big step in the right direction because it does try to control for cow size. I can tell you also, though, that dollar EN is also heavy on cow size. When Angus redid those, and maybe Dawn can tell us more about this, but when Angus redid those, at some point, they have reduced the emphasis on milk in terms of dollar EN. Okay, and I, if it were me, I would put more emphasis on really high milk EPD cattle because there aren't very many environments where you can't overdo milk without having to artificially modify the environment, which is fairly expensive. So, I mean, the dollar M and the dollar EN are kind of doing the same thing because of the emphasis on cow size. Dollar M's got a lot more stuff in it, and it's all good stuff, you know, docility and feet and so on and so forth. I can tell he's, absolutely, please.
I think that dollar EN is directly in the dollar M index as part of it. Okay. If not directly, then certainly those relationships you talked about are there. The other thing we have to remember about dollar EN is it's not a direct measurement of maintenance. It is still based on indicator traits. And so your idea about finding those outliers, still hard to do that because we're still basing that dollar EN off of that, basically the mature weight milk and things like that. Yeah. So indexes are great. They're not perfect, but I wouldn't look at both of them. I think if your goal is trying to find that best maternal female, it's the dollar M that's the one that's going to do the best job for you.
And feed intake is not in either one of them.
Right.
On the maternal side, Dawn, are you familiar with those? Is that correct still? Correct. Yeah, yep. That's my understanding is
dollar M only.
Say again?
Dollar C does, dollar M does not.
Oh, dollar C, sure, because of the post-weaning side's got
Correct.
the feed intake in it.
Right,
yeah.
because the feed intake thing, once again, is that relationship. It's on feedlot cattle, not on cows.
One more question. Anybody has one, just a burning question right now for Dr. Lalman? Got one right here.
What's the magic number then for, and I know it varies from herd to herd, but for efficiency, for milk EPD, what's that average number?
You know, I think, and I didn't have time to go into all the kind of things we think we have discovered here in the last few years, but I think pretty close to my first thought is right now, pretty close to the middle. A breed average is a good place to be in almost all environments. The other thing we've learned is that if you have to have enough milk to get and keep a calf healthy within the first 120 days. After the first 120 days, it doesn't matter very much because if the mother doesn't give a whole lot of milk at day 200 or day 175, the calf just eats more forage. And it's, you know, if you're timed with good quality forage, it's sort of a swap. And so the weaning weights are not tremendously impacted. A little bit by more milk, but not tremendously. So I think somewhere in the middle, and you know, 20, anywhere in that 20 to 28 range, I think is a pretty good place to be for most folks.
I just got a comment, Dr. Lalman, on this question. That's a very good question, Andy. And what Dr. Lalman told you, it's very important that we have enough milk, particularly if that calf get a good belly full of colostrum at birth, and that first 120 days of his life is extremely important. And from my perspective, that's much more important than the total lactation. And we got to be a little bit concerned about that. I think where this thing best fits, you need to know your herd. I think one of the most important things we can do as we're trying to evaluate where we want to go, we evaluate our herd first. Instead of going just buying a bull, we need to buy a bull for the purpose. And we need to figure out our cows before we can make a good decision on what bull we want to buy. And if your cows are not maintaining condition, and I think we sure got a reproductive physiologist in here who would talk about this. If they're not maintaining condition and rebreeding at the level we'd like them, then we need to be concerned about milk and or our feed resources. But those things kind of work together. So very good question, and one worth all of us thinking about and evaluating our cows before we buy bulls.